let's do some LeetCode today. I'm preparing for a Bloomberg interview soon, so let's just take a look at what Bloomberg have in terms of their question bank on here. Right? Sort by frequency. Let's do first one, design an underground system. Okay. So let's see. An underground railway system is keeping track of customer travel times between different stations. They are using this data to calculate the average time it takes to travel from one station to another. Okay. I guess I imagine lots of stations. So let's just say stations, we have A, B, C, D. Okay, so they're using data to calculate average time it takes from one station to another. So we might have some information. We'll probably have some user information and travel time, right? So let's get user travel time. So implement the underground system class. So we have a check-in function that takes an ID and a station name as a string, and also an integer t. Okay, so customer with an the ID is a customer ID. Okay, so user has yes, user has customer ID. I'm just gonna have this written in almost like a JSON format. This is a int. Okay, and travel time is check-in at station name at time t. Okay. And the customer can only be checked into one place at a time. Okay, so some form of a time tracker. We'll see how this might take a look. Let's see what this might look like. So there's a function called checkout. So with an ID, station name, and time. So this is when a customer with ID checks out from the station name at time t. Okay. Okay, so instead of thinking about it like this, we'll just always be having information where just match the way the function takes it. So in customer ID, station name, and time. So this is in terms of int, probably some Linux time, I presume. And then this is a string, so okay. So we have check-in and check-out, so the format is going to be the same. Check-in and check-out. Okay, and then get average time. So this takes a start station and an end station, and this function we want to return the average time it takes to travel from start station to end station. Okay. The average time is computed from all previous traveling times from start station to end station that happened directly, meaning a check-in at start station followed by a checkout at end station. Okay, so no intermediary. And the time it takes to travel from start station to end station may be different from the time it takes from end to start. Okay. There will be at least one customer that has traveled from start station to end station before the average time is called. Okay, so so we can be sure that when we make this calculation, we're not having we don't need a divide by zero check. You may assume that calls to the check-in and check-out methods are consistent. If a customer checks in at time t, then checks out at time t2, then t1 is less than t2. All events happen in chronological order. Okay. So their example here is initiates the underground system, and then check in with these parameters, check in with these parameters, check in, and then check out, check out, check out, and then we call get average time of station. Okay, get average time of station. Where's the station calls? Get average time of Layton and Waterloo. Okay. Explanation. So we check in, this information is stored somewhere. We keep a tally of the user IDs, the station name, and the time, and the start time. Okay. And when we make this call, we just make this compute. Okay, so some constraints here. Okay, this is a lot of information. So let's run some, I guess they have an example here. I just want to do a simplified version in my head here. So every time we check in and check out, we essentially are storing the set of information somewhere. So we have to think about how we want to store this, and such that when we call get average time, we have some form. Well, we have an easy way of doing this. So I guess the simplest ways to think about it is, since if we were to think about this backwards, when we call the get average time function, we have a start station and an end station, right? So if we were to be able to access essentially everyone that has started from start station, and so we first want a list of that. So and then we want all the customers that then moved on to exiting at end station, and then do the time compute of to get the average time, right? So if I were to think about this, I would have, say, start station, which is A. I'm thinking about this in a dictionary. And if I were to access A, a customer would be able to go from station A and get off at any other station, right? So within this station A, I probably have other stations that they get out of. So something like B, C, D. And ideally, when I have this, the best case scenario is I somehow already have the average time, or perhaps which is the total time divided by a number of customers. Right, and so if I already have this information here, get average time, we would be able to essentially have a really fast time really fast result time when we call this function. So let's see if there's a way we can essentially create this structure, and this would essentially look like continue to look like B with station B with A, C, and D. We're just gonna double check if we can check in and check out at the same station. Okay, so I guess we could essentially have a customer check in and both check out at in the same station, and we'll have 2 times 10 to the power 4, which is about well, that's about 2,000 calls to each function. Okay. So let's see. Whenever we call check in and check out, we have these information. Let's see how we might be able to store this. So if we just had a list of customers, if we just had a dictionary of if we just had a dictionary of customers, every time a customer checks in, if we just keep a dictionary of their ID, the station name, and the time, then essentially this is probably to make this look format better like a dictionary, we'll have something like this, right? So thus every time if we were to call a checkout function, we would just look up this dictionary of I guess customers in their system, active customers, I'll call it that. Then we're able to search by the customer ID, get the station name and the time, and then we would be able to do we would be able to subtract the time of a customer when it's checked out, minus the time that it's checked in, and we're able, well, at the same time we have 2 station names, so we first take the station name. So let's use some examples, right? So say we have check-in of 1, we have check-in 1, A, and 0, and we have check-in, sorry. And we check out of customer 1 at C at 5. Right, so we would look at after checking in, we would have a list of active customers dictionary that looks like this. When we call the checkout, we would essentially look up the ID. We would have station name of the check-in station, which is A, and then we also have the so in is A and out is C. And we were able to find the total time that it took, which we can just subtract 5 from 0, which is 5, right? And this, we are able to then immediately add this information to perhaps our average time dictionary, right? So we would have the input A, and then we would have the input C. The the station we went in, which is A, and then the station we came out is C. So we access this part of the, we get into this piece, part of the dictionary, and we're able to then add the total time, right? We can just add on to this, which is, right, so in this case, it'll be 5. Again, this will just be a nested, some nested information in this dictionary. And then we can also add 1 to the total customers, right? So because we can just call num customer, which is 1. And if we were to call get average, the get average time function of A and C, all we would then have to do is to just take the total time here, and we just do 5 divided by 1, right? And then we'll just return 5. Okay. I think doing it this way, because we have a dictionary storing and updating, so adding a record, deleting a record, and searching for a record all takes of 1 time. And also doing the computation, the get average time, all we're doing is we're just doing O of 1 lookup and then doing a division, which are all O of 1 operations. So don't think you can get better than this. So with that idea, let's take a look at seeing how we should go ahead and implement this, right? So first we need a few pieces of information. So when we create ourselves, we've talked about an active customers dictionary, right? Oh, just so in Python, we're going to do self.activeCustomers. Let's go to an empty dictionary. And then we're going to do a self.average time. Average time between stations. I guess just make that naming a little more comprehensible. Just an empty dictionary, and I don't believe we need any other pieces of information here, because we know that the customer would only check in. We can assume the calls of check-in and check-out are consistent. Customer would behave, check-in and the checkout would pair up properly. So we should never have a customer that checks in twice, only checks out once, or checks in twice before he even checks out, which is fine. So in that case, these two dictionaries should be sufficient. So what that means is every time we call the check-in function, we're going to add this customer into the active customers table. So now, for the sake of this question, because knowing that a customer, if we were to call a check-in for the customer, they would have either not entered the system before, or the customer would not have, or must have checked out prior, which means we should expect that when we call the check-in function, this customer doesn't exist in the dictionary. So we can add the null checks later on, but just for simplicity right now, I'm not going to add the null check. That doesn't seem necessary. So in this case, all we're going to do is going to say self.activeCustomers at ID is equal to station name of station name and time of t. That's all we're going happens is when we check out is we're going to first access the information. So we're going to get customer check-in station and customer check-in time is going to, so these are going to equal to self.active customers at ID at, we're gonna say station name, this is to be a string, and the time should also be a string here for as the key. So now we have these information. What we're going to do is we're going to compute the total time traveled is equal to customer check-in time minus t, which is the customer checkout time. And then we're going to go ahead and we're going to say, we're going to, so we're going to check, so if the stations has already been added, so if well, I guess just to note what I'm trying to do here, right? So ideally we want the customer check-in station at customer checkout station, which is in this case the station name. We're going to also say this is going to equal and we're going to also access the we're going to call this the total time is going to plus equal to the total time traveled for this customer, and we're also going to add the we're going to call this num customer. Yeah, that's what we defined. We're just going to add 1 to this, right? So now obviously because we don't know if these entries already exist in the dictionary, we could use default dictionaries. But if you don't want to import anything, one way to go is just going to check, hey, if self dot this, well, if customer station not in. Okay, I see this is going to be really annoying as well. So we're going to actually go just use default dict. So we're going to say from so let's Google this real quick. Python default dict. I forgot how to use this. We're going to say from collections, right? We're just going to say so we should just be able to do this. So default to 0. So when we have that, we also need to say delete the original key in the active customer. Since they checked out, it's no longer a active customer in the system. And then we have get average time. So all we have to do here is actually we just have to call we just have to return this divided by the total time divided by the number of customers. Okay. And that should do it. Now let's comment on all this piece down here. I'm gonna have to verify if the default dictionary can be this. First argument must be callable or none, right? So, yeah, so we're gonna do this little thing here. Return 0. Indentation, line 55. What the heck? Yeah, so this is the part where indent exceeded block. After function definition online. Just delete all of this. Oh wait, definition line 6. Self dot. Huh. That's not good. Key error lighten. So I guess, yeah. So during an interview, just do it the lazy way. If you can't do it the ugly way, if you can't figure out the syntax, sometimes that might take a little bit of time. The idea is that you want to try to get your function to work. So in this case, we're just going to do a bunch of if checks, right? So if customer station in this, in this, right, or else we're going to say equal to so it's is going to equal to station name. And here we're going to have total time is equal to total time traveled. Number of customers equal to 1. And then in here, we're going to also check if the station name is in this part of the key. Because else, we're going to also do this really ugly stuff. Here we're going to say, hey, if this is equal to this, then that means the station has existed before. We're going to just say just do the proper addition stuff here. Okay. Despite ugly, that should do the trick. And then we see if anything else. Total time is up. It's not equal to same over here. Okay. Lastly, here we have start station, end station, start station, end station. So hey, it runs. It's not giving us the right answer. So let's take a look at why. There is a the customer checkout time, right? So everything's negative. It should be t minus h customer check-in time. That was a mistake made earlier. Voila. Okay, we do submission and it works. So okay, so let's take a look at how we might be able to clean this up a little more. Default dictionary with, I guess 0. Nested. So is there a way to make a default dict such that it's also a default for the default dict? Infinite level recursion, right? So the we need about 2 layers deep. So if we are able to do this, then let's see if this would work. So all I'm going to do is just comment this out. And we're going to copy this over here, uncomment this. Okay, delete this as well. Key error or total time. essentially want this to also initialize to 0. Right, so yeah, a slightly more obscure way. This is not as clean, but I think this will do for now.